What does a real Kubernetes cluster look like when you only have $2 a month to run it? In this episode of KubeFM, we're joined by Varnit Goyal, a senior software engineer at ClearStreet. Varnit breaks down how he built a full multi-node Kubernetes cluster for just over $2 a month using Rackspace Spot Instances, including the bidding strategy, region selection, and instance types that make it stable enough to use. We dig into the operational side of on-spot capacity, handling preemption, monitoring node reclamation, and using the multi-region worker strategy to reduce downtime. This is a practical, experience-driven discussion about what Kubernetes really needs to function, and which patterns still hold when you remove budget as a safety net. This episode is sponsored by LearnCube. Since 2017, LearnCube has helped engineers from all over the world level up through Kubernetes courses. Courses are instructor-led and are 60% practical, 40% theoretical. Students have access to course materials for the rest of their lives. Courses are given in person and online to groups as well as to individuals. For more information about how you can level up, go to learncube.com. Now, let's get into the episode with Varnit.
You're tuned in to KubeFM.
Varnit, welcome to KubeFM. What 3 emerging Kubernetes tools are you keeping an eye on?
Well, eBPF is something new, which I'm keeping an eye on. It's an interesting technology, and it lets you experiment without this sidecar overhead in Kubernetes. So that's the number one tool I'm looking at. Other than that, I'm interested in MethodLB because I do home labbing, and MethodLB plays an essential role when you're trying to build your own Kubernetes cluster at your home. Then there is this Database. So basically, what I found out in other companies and my companies as well, there is always a development environment, a dev environment, which a lot of developers use. It keeps breaking. So Database is something which lets every developer spawn their own sort of environment. So it really helps in the productivity. So yeah, Database is something which I am sort of actively exploring right now. So yeah, these are the 3 tools I usually am interested in.
Very good. And Varnit, for people who don't know who you are, can you let us know a little bit more about what you do and where you work?
Yeah, sure. I'm not senior software engineer. I am more like a full stack developer, not really associated to, or don't want to associate myself to a particular technology as per se. I consider more of myself as a problem solver rather than, a software developer for a particular technology per se. So yeah, I'm working as a senior software engineer, and I currently work at a company called ClearStreet. It's a prime brokerage platform based in US. They help, institutional clients and active traders to trade in the US markets. So yeah, that's what I am. Outside of my work, I am interested in exploring technologies. I'm interested in home labbing, automations, and I just build these tools which help other people and help me to automate my own life.
Great.
Yeah.
And how did you get into cloud native in the first place?
Well, if you are in a software industry, it's really, really hard and almost impossible to escape from cloud native itself because it's everywhere, right? So the companies that I'm currently working in, the companies that I've worked in the past, they all usually run all their workload on Kubernetes, and they all usually, run their workload in more or less like a cloud native way. So it was always, part of the life cycle as software development. So yeah, that's how I came across these cloud native tools and Kubernetes in general. So yeah, and that raises the curiosity to explore more of inside the Kubernetes, more inside the cloud native, tapping into the power of cloud applications.
And what were you before cloud native?
Well, as per se, I was born into the cloud native era. So when I started development, I joined companies. It was cloud native already there. So there's not much context as per se for me, what I was doing before the cloud native era. But yeah, because when I was actually gone into the software development, it was already there. So.
Now, the Kubernetes and cloud native ecosystem move very, very quickly. How do you stay up to date with all the changes that are going on? What resources work best for you?
But I don't want to name a particular resource. Medium is a good one. I read Medium articles. Reddit had some really good threads. So there are obviously multiple resources. I watch videos, I read articles, hear podcasts. So there are definitely multiple resources you can refer to, keep updated with the Kubernetes and cloud native era. But what I prefer to do is when a new technology comes, I try to build some MVP or some tooling around it. So I think when you build stuff with this new technology, you learn a lot more than just reading something or watching a video. So, for example, I recently was exploring eBPF, so I'm just trying to build some observability layer around the eBPF and Kubernetes, just to get rid of this sidecar overheads.
And Varnit, if you could go back in time and share a career tip with your younger self, what would it be?
Build more, consume less. So that's number one tip I've learned. When you build stuff, you solve real world problems. You learn a lot more than you just consuming a video or reading an article. So yeah, that is something which I've learned.
As part of our monthly content discovery, we found an article that you wrote titled Run Kubernetes Clusters Under $2 a Month. That sounds pretty exciting. So, for many developers that are out there, they assume that Kubernetes requires enterprise level budgets, often deterring individual developers and small teams from using it because they say, from a cost perspective, it's just a nightmare, just something they simply can't afford. What prompted you to explore ultra low cost Kubernetes solutions, and what was your initial goal?
Yeah. So, like I said, I was always fascinated with the Kubernetes, and it definitely looks like an enterprise tool because you work in a companies, they run a lot of nodes, a lot of pods, everything is there. So I always want to learn like how these things works, how Kubernetes work in general, right? So I was exploring solutions around it. I explored Minikube, that allows you to run a Kubernetes cluster in your own system. But they were not very satisfying because they are more like a very cut down version of how the real Kubernetes cluster looks like. So I was not really satisfied with Minikube and other uh, Docker Desktop allows you to run the Kubernetes cluster. So I wanted to always experience the full-fledged Kubernetes, Kubernetes clusters running on multiple nodes or multiple pods. There is a network layer on top of it. So I wanted to experience that. So I started exploring AWS, exploring DigitalOcean, Akamai, other cloud providers, where I can actually spawn this Kubernetes cluster. But they were mostly on, a lot of expensive side just to toy around. And since I live in India and the purchase parity is also a thing, it's not very affordable for me to spawn a full-fledged Kubernetes cluster just to play around it. Um, so yeah, that is what where my curiosity came in, like how to actually spawn a Kubernetes cluster, a full-fledged Kubernetes cluster to play around, and at an affordable cost. So yeah, that's where I started exploring it.
Now, you mentioned Rackspace Spot as a game changer for affordable Kubernetes. Can you explain what Spot instances are and how Rackspace Spot differs from traditional Kubernetes hosting?
Yeah, so I was one day I was just visiting some Reddit thread, and someone just mentioned, "Hey, Rackspace is providing really cheap machines in the form of Spot instances." So yeah, I just went ahead, exploring it. So what I found is that they really provide Spot instances. And for the audience, people who are not really familiar, what is the Spot instances? So I'll just do a brief thing. There is so basically every cloud provider out there, they have some sort of a buffer capacity that they have to keep to support the spike loads and the demand that might happen. So this buffer capacity, it keeps lying around empty. So what they do is they usually bid this capacity at a really really low cost on a condition that they can take this capacity back when needed. So suppose as a cloud provider, I have 100 machines in buffer and only 10 are being used right now. So these 90 machines capacity is sort of like wasted. So what they do is they provide you these 90 machines for a really cheap price on a condition that they can take it back anytime it's if demand comes. So that's what the spot instances is. So Rackspace provides these spot instances. The thing that the proposition that Rackspace Spot is providing is they allows you to use these spot instances with the Kubernetes cluster. And the interesting thing is this Kubernetes cluster will be managed by them. So you don't really have to spawn the Kubernetes cluster control panel by yourself. What you can do is have some spot instances and just connect them to their own managed Kubernetes cluster. So this way you can really enjoy a full-fledged Kubernetes cluster at a really cheap cost. Like you can even make a single node uh, Kubernetes cluster, and it will be actually act like a full-fledged Kubernetes cluster. So that was a very very interesting idea for me. Okay, like now finally I will be able to enjoy the power of full Kubernetes cluster and the pricing will also be very, very affordable. So yeah.
And affordable is the right word to use, as the price that you achieved is remarkably low, $2.16 per month for a 3-node cluster. Can you walk us through the specific bidding strategy and instance selection that makes this possible?
Yeah, definitely. So obviously, spot instances are tricky to get it right because, of course, they can be preempted, right? That's a tricky part. So what bidding strategy I've used is, so the bidding strategy and Rackspace Spot, they started at $0.001, which is really cheap. So you can just have a starting number as this, and you don't need to bid a very, very high because that will shoot up the cost a lot. What you can do is choose instances which are not default. So, for example, I chose memory optimized instances. It doesn't really matter. I want to run test workload. So, you can choose compute instance or memory optimized instance. Why? Because they are not the default option in Rackspace Spot. So, that's why um, they are less in demand. That's what I found out after experimenting with multiple configuration. Other than that, I just bid from 0.01 to something like $0.2. So just choose the highest amount to the budget you don't want to extend. You don't need to choose a very, very high amount. It's fine. So yeah, that's my bidding strategy. And the other thing is how I actually globally distribute my nodes to have further reliability. I think the tricky part is you get your spot workers into regions which are not very popular. So, for example, Hong Kong, Australia, like they are not default regions. They are not the regions where the lot of demand is expected, right? So, I spawned a few instances in Hong Kong region and Australia regions, and surprisingly, they never get preempted because there was no demand at all uh, in these regions. So, I think the tricky part is because it's a testing workload, it doesn't matter. It's better to just spawn these worker nodes into regions where the competition is low. That's why your pricing will always be low, and the chances of your machine getting preempted is extremely low. Like it almost never got preempted for me when I was spawning my nodes in the Hong Kong and Australia regions. So yeah, these are a few tips you can use to keep the cost really low and also keep the your cluster stable.
Spot instances come with the inherent risk of being preempted when someone bids higher. What immediate monitoring solution did you implement to stay aware of potential node reclamation?
Yeah, sure. So, simple way to do it is that Rackspace Spot, they provide you with sort of a Slack webhook alerting system. So once they're about to preempt your instance, they send you an alert on the Slack. You can configure that Slack webhook where they'll send you this alert. You'll get some, I think, 5 to 10 minutes or something like that to take an action before it actually gets preempted. So I have configured this webhook on my personal Slack. They send me the alert. You get a time to take some action, maybe increase the bid or spawn a new instance in some other region. What I personally did is I just configured a really simple script, which is triggered by this like webhook. So they send us like webhook, and my script just spawn an instance into some other region and just delete that instance from that particular region where it's going to be preempted. And since Kubernetes is really good at rescheduling your workload, it Kubernetes is able to detect that, okay, this node is no longer healthy. It will just reschedule your workload into some other region. So that's how I am handling this thing right now. And it's working pretty well for me.
And beyond monitoring, you implemented a multi-region strategy for improved reliability. Can you explain how geographic distribution helps with spot instance stability?
Yeah, definitely. So it works like that. So, for example, you have few worker spot nodes into Australia region, and there is a a match or a popular match coming up in Australia. So, and the demand suddenly increase in the Australia region, and that's why your nodes get preempted. So, what multi-region provides you is protection against these kind of demands and spikes. Uh, so yeah, that's how it is.
Now, let's talk a little bit more about a major budget concern. Load balancers typically cost around $10 per month, which would blow your $2 budget, completely out of the water. What creative solution did you find to expose services to the internet?
Yeah, sure. So definitely, I think load balancer is one of the blocker that always been there. So when I was exploring Kubernetes and other cloud providers as well, so for example, DigitalOcean, they also have a very expensive load balancer. By expensive, I mean it's $10, but yeah, for the person who is just trying to play at Kubernetes, it's expensive. So, so yeah, Rackspace Spot also provides a load balancer, and there is no really real concept of spot load balancer. Like load balancer is actually always sort of a production level component. So that's why it costs more. So in Rackspace also, it is costing around $10, which is obviously going to shoot up the budget, which I did not want. But on the same time, I also wanted to expose few of my services to the internet. So I am also a big fan of how Tailscale uh, works, and also they about their very generous free tier. So I was exploring Tailscale, and they have something called Tailscale Funnel, and they also have an operator for Kubernetes. So I was exploring around it, how it works, and I found a way, okay, to set up the Tailscale operator and a Kubernetes cluster, and I was able to expose the services over the internet. And if you're not even interested into exposing it internet, the simpler way is to expose it to Tailscale network, and then you can access your service from any device which is connected to Tailscale, because they sort of provide a VPN mesh, which through which you are able to sort of access your private devices. So they create some sort of a virtual network layer on top of all of your devices, and your devices can communicate together, similar to a private network. And in case you really want to expose it to public, you can use Tailscale channel to expose it to public. Both options are available and pretty simple.
For developers that might be unfamiliar with Tailscale, this could be a new approach to service exposure. Can you walk through the basic setup process for integrating Tailscale with your Kubernetes cluster?
Well, it was pretty easy. Tailscale documentation is good around this topic. All you have to do is they have some sort of a help chart which helps you to set up a Kubernetes operator. So you can just install those Helm chart in your Kubernetes cluster. Then you have to create some OAuth application to authenticate your Kubernetes cluster with Tailscale. And then you have to just set up some auth rules in your Tailscale dashboard. So I think within 5 to 10 minutes, you should be able to set it up. It's quite simple. It's not very difficult. If you're familiar with basics of Kubernetes, it should be good enough.
You provided a complete example deploying Nginx with Tailscale exposure. Can you explain how the Tailscale ingress annotation works and what makes it different from traditional ingress controllers?
Well, to be honest, it's very similar to how you expose your application through a traditional ingress. So it's about you just have to add some sort of metadata annotations with Tailscale construct, and it should be done. Like the Tailscale operator should be able to detect these annotations and should be able to expose the service. So it's not it's not any different than exposing a service through a traditional ingress. Like it's very much same. Only the annotation part is different. But the way you do it is it's very, very similar.
Okay. And this setup seems perfect for development and learning environments. What types of workloads have you successfully run on this ultra, low budget cluster? And what are the practical limitations?
As a developer, you run into many dependencies. So, for example, as a developer, I often need a Kafka, Elasticsearch. These are very heavy dependencies, and if you run it on your local system, it usually ends up jamming your system. So I run Kafka cluster, Elasticsearch, all Postgres, all kind of development dependencies into my Kubernetes cluster. I also run some MQTT servers, which is helping in my home automation stuff. Other than that, I also run some through DataSpace, some dev environment. So when you want to compile some heavy things, you can just offload it to the Kubernetes cluster, and it will compile it for you really fast. So I'm primarily using it to keep my development machine light and offload the heavy things to my cluster. And yeah, I think that's majorly what I'm using it at. About the limitation part, it's perfect for my workload. I think, and I don't see any limitations as such. Uh, One thing is this uh, about the limitation. Like I can't really think of any limitations as such of now. Maybe we can talk later on. So,
Okay. For teams or individuals that are currently paying hundreds of dollars monthly for Kubernetes, this approach might seem too good to be true. What reliability metrics or uptime have you observed with the setup?
I think it's pretty reliable. So for me, it's surprisingly too good to be true too. Like, but the way if you spawn the nodes, worker nodes into multiple regions, and if you have a right bidding strategy, it's very, very reliable, I'd say. Like I never really had any problems I've been running my workload from the last 3 to 6 months, and I never really ran into any reliability issue. But I'll definitely recommend, to have a real load balancer rather than Tailscale, some good metrics. Like I'm using Slack webhook, but yeah, probably some Datadog or some other, bigger metrics platform can be used to monitor it well and uh, make it more reliable. But yeah, for me, it does very, very reliable. Never had major issues with it yet.
So, this $2 cluster is a remarkable and ingenious project that proves what's possible with creative thinking. However, it's clearly not production ready as is, or is it? If you were forced to use spot instances in production to achieve similar cost savings, what would you need to fundamentally change about this architecture?
Well, yeah, it's definitely not a production ready project, at least not in the current form. But it's very, very easy to actually make it production ready. What you need to do is Rackspace provides you some on-demand nodes too. So what you can do is you can use a combination of spot nodes and on-demand nodes uh, to make it production ready. So yeah, I think the best way is you can start with this really cheap instances, and when your application is ready to fly, just add some on-demand instances, add a real load balancer, and you are good to go. So it's really easy to upgrade. You don't really need to change the fundamentals of your cluster. Okay.
The multi-region approach worked beautifully for your hobby cluster, spreading risk across geography. But if you had to implement this same multi-region distribution for a real production workload, what specific challenges would force you to rethink this simple setup?
Well, I think latency plays a really important role when you do a production setup. So you definitely want your nodes to be near your user, right? So that latency for user is reused. So what I would do is I would spawn some nodes to the place where my users are, and I'll distribute the workload into two types. One which is user facing, and one which is not real time. It might not be user facing, and I'll use Kubernetes affinity to schedule the nodes which is user facing to the nodes which is near to my user, and I can spawn rest of the nodes to the spot workers, which might be uh, hosted far away. It doesn't really matter because latency is the only thing which is stopping you to actually geographically distribute a lot of nodes.
Tailscale was a clever workaround that solved your load balancer cost problem perfectly. But if Tailscale was your only option for production traffic, perhaps due to specific security requirements, what architectural changes would you make to handle thousands of concurrent users?
Well, first of all, Tailscale free tier only provides a limit of 100 users, 100 devices as such. So I would say I will definitely go with Tailscale paid tier, which supports more user and more reliability. So if you have an internal applications which you really want to distribute across your company or enterprise, I think yeah, Tailscale is a good option. You can just switch to their paid tier, use Tailscale VPN for internal workloads. For public workloads, however, I will prefer to use a public load balancer. So Rackspace provides a load balancer at $10. You can just, and it's really easy to use. All you need to do is just change an annotation in a deployment script, and it will just spawn a Rackspace load balancer rather than a Tailscale load balancer. So yeah, I'll say for production workload, uh, I'll use a combination of Tailscale plus Rackspace load balancer. For internal workloads, Tailscale is more than fine. For user-facing workloads, however, I must go with the Rackspace load balancer.
After running this $2 cluster experiment, you've learned valuable lessons through extreme constraints. What specific Kubernetes patterns or practices that you discovered would you actually bring to a well-funded production environment?
I think the number one lesson that I've learned by running it is creative thinking can takes you very, very far. And other than that, is about the Kubernetes is that it's really good at rescheduling and detecting unhealthy nodes. So when I was experimenting with it, my nodes were getting preempted, but Kubernetes was really good at rescheduling the workload into some other places, and it worked. Like it works beautifully. If you uh, Kubernetes is really good at rescheduling your workload and detecting unhealthy nodes and unhealthy pods and stuff. So I think that's one of the best thing I loved about Kubernetes. Other thing is, so like you can really build fancy stuff around Kubernetes, like fancy networking layer, fancy metrics, and all that. But what I've learned is, if you keep it simple, it works. And so you don't really need a lot of fancy things to start with Kubernetes. Ultimately, it's just a really good workload scheduler. If you think in that terms, I think things get easier.
All right. And, Varnit, you seem to have put a fair amount of time into this project. What's next for you?
Definitely. So I'm much of a tech enthusiast. I keep exploring stuff. So I'm currently working in eBPF domain mostly. I'm trying to explore the power of eBPF, how to improve the tracing and Kubernetes, how to improve the tracing for applications without much of an effort for developers. So currently I see, many developers, they have to manually implement the tracing and all. But through eBPF, you can actually trace this application calls and improves the tracing automatically. So I'm exploring around that mm, eBPF capabilities in observability space. That's what I'm working on. So looking forward to build some open source tools which can help the community build better stuff. So yeah, that's what I'm doing.
And if people want to get in touch with you, what's the best way to do that?
Yeah, I'm very, very active on LinkedIn. So anyone wants to connect, just reach out to me on LinkedIn. I usually open LinkedIn multiple times in a day. So yes, I'll get back to you whenever I can.
Fantastic. Great. Well, Varnit, thank you so much for your time today sharing your experience. Look forward to hearing about new projects that you're working on in the future. Take care.
Sure. Bye.
You're tuned in to KubeFM.